So with rational functions, we have to consider asymptotes, vertical asymptotes. Those are whatever makes the denominator zero when it's reduced. There's other asymptotes that we'll talk about. Horizontal asymptotes. There's 3 different cases of horizontal asymptotes. We'll talk about all 3 of those here in just a little bit. Letter A, if the numerator has a lower degree than the denominator, we have a horizontal asymptote at y equals 0. If the numerator and the denominator have the same degree, we will have a horizontal asymptote located at the ratio of the leading coefficients. When we get to that one in a second, it'll make more sense. If the degree of the bottom is bigger, if the degree of the bottom is less than the top, we will not have a horizontal asymptote. However, part C, if the numerator is of degree 1 more, exactly 1 more, not more than that, exactly 1 more than the denominator, we will have an oblique or a slanted asymptote. It's going to be a line, and we will need to find the equation of that line that gives us that slant asymptote, and we'll do that by using long division. Ew. Here's a special note about asymptotes. There can be more than one vertical asymptote. That's okay. Or it might not have any. That's okay. If there is a vertical asymptote, a graph will never touch a vertical asymptote. There can be, at most, 1 horizontal or oblique asymptote. That's it. Just 1. It is possible for a graph to actually touch a slant or horizontal asymptote. And we'll see an example of that in a little bit.
It's a lot of words.
Oh, big word.
Screenshot.
So we have 3 rational functions here. And we're going to give the equation of any vertical, horizontal, or oblique asymptotes for each of the graphs. So, part A, f of x is equal to x plus 1 divided by 2x minus 1 times x plus 3. In order to determine vertical asymptotes, the first thing we must do is make sure it's in simplest form, meaning it's factored completely and nothing cancels. Example A, everything is in fact factored completely and nothing cancels. For those of you that are not taking notes, I will kick you out of the classroom, which will prevent you from doing screenshots. All right. So since A is already in simplest form, to find the vertical asymptotes, we want to find what values of x make the denominator 0. So you will set each factor to 0. So part A, let's look for vertical asymptotes. So we set the factors at the bottom to 0. So we have 2x minus 1 equals 0, and we have x plus 3 equals 0. And those are 2 very simple linear equations that we can solve. The first one will add 1 to both sides and divide by 2. So we have a vertical asymptote at x equals 1/2. For the other one, subtract 3 for both sides. We have x equals -3. So this function has 2 vertical asymptotes. One's at 1/2 and the other one's at -3. Doesn't have a horizontal asymptote.
That was a crooked line.
I don't care.
There's oblique. Just
What is the degree of the numerator?
Oh, it's 2. Wait. One, 2.
Degree of the numerator
It's 1.
is 1. This is x to the first power.
Yeah.
Okay. What is the degree of denominator?
2.
2.
Why?
Because
Because it's Dr. Little.
when you FOIL out 2x minus 1 and x plus 3, you get 2x squared.
Okay, so the leading term on the denominator is 2x squared. And because it's squared, it's degree 2.
Wait, hold up. Where'd you find that?
The bottom has to, if you multiply it together, FOIL
Oh,
it.
okay.
2x times x is 2x squared. Okay? So here we have the numerator degree is less than the denominator degree. So what's happening here? Basically, I have x divided by x squared. And let's say that that number x is really large. Or let's just say the degree is 0 instead. Let's just go with 1. I've got 1 candy bar. I'm going to take that 1 candy bar, and I'm going to share that 1 candy bar with the entire population of the earth. How much candy bar will each of you receive?
Not enough to see.
Essentially what?
Nothing.
Nothing. Okay, so when the degree on the bottom is larger than top, or when the degree at the top is smaller than the degree at the bottom, you'll have a horizontal asymptote at y equals 0. I'm taking that 1 candy bar, I'm dividing it by the entire population of the earth. You essentially get nothing. Okay. And that's all we need to do for part A. We found the vertical asymptotes, and we found that there was, in fact, 1 horizontal asymptote. Questions on part A before we look at part B? Okay. Part B, we look at it. Does it appear to be completely factored? Yeah, there's nothing I can do with it. Okay. So, vertical asymptotes. Does it have any?
Be 2x plus 1.
I'm hearing 2x plus 1, I'm hearing x equals 3.
Okay. You-
Why is it x equals 3?
Because of the negative.
You set the denominator. It's got to be, for vertical asymptotes, we're looking at the denominator, okay? So x minus 3 equals 0, which means x equals 3. I have 1 vertical asymptote at x equals 3. Now let's look for horizontal. The degree of the numerator,
1.
1.
degree of denominator.
1.
So degrees are the same.
Oh, it's not. There's no.
Degree, is that 9?
When the degrees are the same, let's look at it this way. If I ignored everything except for the power piece of each numerator and denominator, all I'm looking at is the 2x divided by x. If I gave you 2x divided by x, could you reduce that?
Yes.
What would it be?
2.
2, because the x's would cancel. Okay? When the degrees are the same, we will have a horizontal asymptote at the ratio of the leading coefficients. So in this case, it's y equals, and I'm going to go ahead and write it out as 2 over 1, just so you can see where those came from. Those are the leading coefficients, right? And of course, that reduces to 2. we have a horizontal asymptote at y equals 2. Had the bottom been 3x minus 3, the horizontal asymptote would have been y equals 2/3. Y'all good with that? Questions on part B? Now, what are you thinking?
Back to part one,
Part A?
yeah, that.
Okay.
So what would happen again if it was the denominator that was greater than the numerator?
This does have a denominator greater than the numerator.
This is backwards.
Oh, you're talking about part C?
Oh, yeah, sure.
The one we're about to do?
Yeah, sure.
Okay, let's go to that one then. Because if you think about it, there's only 3 things that can happen. Either the top is smaller, they're the same, or the top is bigger. Can you think of any other possibility? There's nothing. Either the top is small, they're equal, or the top is big. Part C, we have the top big, but before we talk about horizontal, let's talk about vertical. Vertical asymptote, we're at
X.
Two.
x equals 2. Y'all okay with me taking shorter notes as we go on? Instead of rewriting the same thing over and over and over again? If I need to write it again, someone let me know, please. Okay, so let's talk about horizontal asymptotes. The top degree is what?
It's 2.
The bottom?
1.
Okay, so here we have the numerator degree is greater than denominator degree. There is no horizontal asymptote. But what was that other statement? If the degree of the numerator is exactly 1 more than the denominator, then there's an oblique. Is that where we are now?
Yes.
Degree of the top is 2, degree of bottom is 1. There's a difference of 1. Okay. The difference of 1
We have to modify.
in the degree. So we have an oblique asymptote. Okay, what was the numerator?
X minus 2.
X
X
squared
squared
minus
plus
1. Oh, plus 1.
Plus 1? Divided by denominator?
X minus 2.
Okay. We're going to do long division, and we're actually gonna we're gonna throw away the remainder. Don't even need it.
Wait, so is there only an oblique when it has a difference of 1?
Yes. So, long division. X times what is x squared?
X squared.
X.
X times x.
Yeah, okay. Yeah.
X goes into x squared x times.
Oh, yeah.
Now I'll take that x and multiply it by x minus 2. X times x,
X
x squared. X times negative 2, negative 2x. In long division, what's the next step that we do?
Cancel.
Subtract, but that's not how I do it. Change the signs and combine, which is subtracting. But if you don't change the signs, you might forget to change all the signs and you might mess up on subtracting. Okay? So I will change my signs and combine all like terms. X squareds,
Just cancel.
gone. So those are gone. I still have a 2x, and I still have a plus 1. I combine all like terms there. X times what is 2x? What kind of a 2? A plus 2. I'll take that plus 2 and multiply it by x minus 2. 2 times x is 2x. 2 times negative 2 is negative 4. Change my signs. Combine. And what do we get?
You get 5.
5. Does x go into 5?
No.
No. So that's my remainder. I throw it away. I don't care. We have an oblique asymptote. At y equals x plus 2. I took this x plus 2 and put it right there.
What if the difference was like a different number?
We're not going to worry about that in this course.
Okay, so it's never gonna happen?
Yes, it does. If the difference was 2, the asymptote would be a parabola. And you would still do long division to figure out what it was. But we're not going to go there. For this course, we will do vertical asymptotes, we will do horizontal asymptotes, and we'll do obliques. That's it. Okay?
Oh, yeah, I'm just gonna stop that real quick.
And moving on.
No.
Yes.
Okay, then let me screenshot.
You should have already done that.
Well, I was trying to write things down instead.
You're trying to educate yourself, Nicole.
Okay, here are the 7 steps. We're about to graph some of these. First thing we want to do when graphing these is establish where are the vertical asymptotes, if any. Step number 2, find the horizontal or oblique asymptotes. Step number 3, if Q of 0 is not 0, meaning we don't have a vertical asymptote at 0, then we want to find the y-intercept by plugging 0 into the function. That'll get us the y-intercept. Step 4, plot the x-intercepts by setting the numerator to 0. Anywhere the numerator is 0, that is going to be an x-intercept. Step 5, we want to determine, will the graph intersect the non-vertical asymptote? To do that, you take the function and you set it equal to the horizontal asymptote or oblique asymptote. Step number 6, plot any points. We will choose an x value in each domain interval determined by the vertical asymptotes and the x-intercept. Okay, what step 6 means is when we plot the vertical asymptotes and the x-intercepts, we're going to be breaking that domain into pieces. You want to plot points in each of those pieces to figure out what is the graph doing in those sections of the graph. And then step 7 is you draw your curve. When plotting the points, use your calculator. I'm good with that. You don't have to do the math and plug them in and do it manually. However, don't look at the graph. Okay? Look at the graph to check yourself, but don't look at the graph while you're plotting it to make sure you're headed in the right direction. Okay, here we go. We're going to graph. I want to graph f of x equals x plus 1 over 2x squared plus 5x minus 3.
That looks not bad.
When you're looking for horizontal or oblique asymptotes, you want to use the original problem. So this is where we want to be to find the horizontal or obliques. What's the degree of the top? Degree of the bottom? I'm sharing a candy bar with the world. Do we have a horizontal asymptote?
0.
At 0.
Yes.
Okay.
What?
Basically, what we're doing is we're looking at the leading ones. We're kind of looking at y equals x over 2x squared. Can you simplify that? One of the x's cancels. So that would be the same thing as
X.
1 over 2x. I'm taking the number 1, dividing it by extremely large numbers, which means it's going to be 0, right? Okay. I have a horizontal asymptote at y equals 0. And I'm just going to jump all over apparently. Okay. Vertical asymptote. To find the vertical asymptote, we need to find what value or values will make the denominator equal to 0, which means we have to factor 2x squared plus 5x minus 3. How does that factor? What is a times c going to give us?
Oh, hold on. 6, -6.
Negative 6. What two numbers multiply together to get negative 6 but combine to 5?
1 and 6. Wait, 1
No.
and negative 1 and
Numbers,
6.
well, that's 3 and 2, right?
Negative 1 and 6. Makes
To make
5.
five.
Negative 1, yeah. Negative 1 and 6.
Oh.
Negative 1 times 6 is negative 6. Negative 1 plus 6 is 5.
Oh,
Okay? So the denominator now is
also
2x squared minus x plus 6x minus 3. Right? I just rewrote it. What does 2x squared minus x have in common? X. Factor an x out, what's left?
X, no, 2x. That's a, wait, 1,
Minus 1. Don't forget that. What does the next pair have in common?
3,
What kind of a 3?
negative.
Positive 3.
Oh, yeah,
You look at the first term. Take a 3 out, what's left?
2x. Minus 1.
Minus 1. What do those two terms have in common?
2x minus 1.
Okay, these two terms here have a 2x minus 1 in common. And I'm left with?
X plus 3.
Okay. So now at the bottom is completely factored. Does anything cancel? Nothing cancels? Okay. So we have two vertical asymptotes. Where are they? Two x minus 1.
And x plus 3.
X plus 3. So to solve 2x minus 1, I will add 1 to both sides and divide by 2.
So it would be x, yeah.
1/2. And the
x-
other one?
X equals negative 3.
Okay, so let's draw those. I've got a vertical asymptote at 1/2. And I have a vertical asymptote at negative 3. Questions so far? Okay. Let's go back here. Step number 1, find the vertical asymptotes. We did. Step number 2, find the horizontal or oblique. We did that too. We did them in a different order, but that's okay. Step number 3. Can I plug 0 in to the bottom? Is 0 okay in the bottom?
No.
The only two numbers that are not okay on the bottom are 1/2 and negative 3. Okay? So I can plug 0 in.
Oh no, 0 can be on top, right? Because then it would be 0.
I'm talking, the value of the denominator can't be 0. But x can be 0 in this case.
Oh, okay.
Okay? So let's find the y-intercept. The y-intercept is found by figuring out what f of 0 is. If I plug 0 into this, I get 0 plus 1 divided by 0 plus 0 minus 3, which is
1/3.
that is the point 0, -1/3. 0, -1/3.
Yeah, that's a 3.
Oh, which one? Looks like a cherry.
Plot the x-intercepts, if any, by solving f of x equals 0. This will correspond to the zeros of the numerator. Okay, well, zeros of the numerator. So x-intercepts. That's when the numerator equals 0. When can that happen? Like, can you stand?
I have a question.
Go ahead.
For the y-intercept one,
Okay.
did you just put 0 for all of it? Or all of the x's?
No.
Anywhere on the y-axis, the x value is 0. I don't care where you are on this line, the x value at that point is going to be 0. So by definition, to find the x-intercept, to find the y-intercept, you let x equal 0.
Oh, okay.
Okay?
Wait,
I'm listening.
how do you get 0 plus 0 minus 3 then?
0 squared is 0. 2 times 0 is 0.
Okay.
Plus 5 times 0 is also 0. So 0 plus 0 minus 3.
Okay.
Okay. No, you don't. You're good. So I set the top equal to 0 to find the x-intercept. I have an x-intercept at -1. Right here. Notice that point is on the horizontal asymptote.
Is it curving right there?
There's some curve going on, yeah. Okay, that was step 4. Step 5, determine whether the graph will intersect its non-vertical asymptote. Okay, this problem is not really a good example for that because we've already figured it out. Okay, obviously it touches right at that point right there. So that part's already done. Step 6, plot selected points as necessary. Choose an x value in each domain interval determined by the vertical asymptotes and the x-intercept. So what has happened here is my domain has been broken up. It was broken at -3, we have an asymptote there. It was broken at -1, we have an x-intercept there. It was broken at 1/2, we have a vertical asymptote there. So this domain has been broken into 4 pieces. Y'all good with that? 1 piece, 2 pieces, 3 pieces, 4 pieces. I need to choose at least 1 point in each of those 4 areas to determine where this graph is at. So I need a number less than -3. -4. I need to determine f of -4. I need a number between -1 and -3.
Between
-2 sounds like a great choice. I need a number between -1 and +1/2.
0.
0.
And we already have that point.
So it'll be 1.
So we're good there.
Oh.
We're good there. I've already got a point. So I know what's happening to this graph. In fact, I can kind of graph it. I know that from here, it's going to come here and it's going down because it cannot cross a vertical asymptote. I know for sure that's exactly what the graph is going to do. What I don't know is to the left of -1. Is it coming back down or is it going to go back up? That's why we have to find a point in between there. That's why we need to figure out what f of -2 is. I need a point greater than 1/2.
5.
Here, let's go with
Let's go with
Oh,
1.
Christ.
One.
That's boring. Why'd you ask if you want my answer?
Okay? If I can get those 3 points, it's gonna give me a great idea of what this graph is doing.
Oh my god.
So, my numerator is x plus 1. Denominator is 2x squared plus 5x minus 3. I want to go to the table right now. Don't cheat and look at the graph. 0, negative 1/3, we've already got that point. I want f of 1. F of 1 is 1/2. So the point 1, positive 1/2 is right there. I can plot that point. I need negative 2. At negative 2, I'm at 1/5.
so it's going up, right?
Negative 2, I'm at 1/5, so I'm right there. I'm above the asymptote, so I can see what's happening there. And negative 4,
Why is it error on negative?
there's an asymptote there. You're dividing by 0 there.
Oh.
You can't divide by 0. At negative 4, I'm at negative 1/3. Here's negative 4, here's negative 1/3. Okay. Folks, that's all the points I need to graph this thing. I know that because it's going through that point, the graph is confined to this area, which means it's very close to the x-axis, coming down, can't cross. So there it is there. I know that between negative 4 and negative 1, I'm sorry, negative 3 and negative 1, it's going up. And I know it can't cross a vertical asymptote. And based on this point, I can see that once we get past 1/2, the graph is confined to the first quadrant, right? So it's going to come very close. It's approaching that asymptote, and it's approaching this asymptote. Kyle, you want to sleep here, or you want to go sleep in Chris' office?
Think you let me sleep on this couch?
You can go ask him.
I'm good.
Why don't you go ask him?
I'm good.
Okay, so there's my graph,
This couch is pretty comfy though.
and how's it look?
It looks like you
Two
cheated.
lines are straighter.
Okay, so I'm just gonna copy that and act as if I completely
It
understood what
looks like
you're
it's such a
saying.
zero. Actually, kind of looks like a good couch. Can you go back to your calculator one more time?
Do what?
Can you go back to how did you put it in lines equals? Just like the original equation or the?
Yeah, you just put
one
the
you-
original equation.
Okay. Cause I put it in the equation and I got an error.
Y'all said it looked like it was touching the the x-axis. Doesn't, does it?
No, just gets smaller and smaller.
But I can see how that looks like it might have.
Yeah.
All right. All right. Screenshot it if you need to. I'm about to go to the next one. Got to graph another one.
Yay.
I keep screenshotting as if I'm never gonna look at these again.
Yeah, I only screenshot the ones where I know I'm gonna have to end up looking back.
I know. I just wanted to
Okay. 2x plus 1 over x minus 3.
Good.
Do we have a vertical asymptote?
Yeah.
Hold up. Let me read.
At 3?
Oh, yeah.
at x equals 3, right? We took the bottom, x minus 3, and set it equal to 0. X minus 3 equals 0. Add 3 to both sides. We have vertical asymptote at 3. Does it have a horizontal asymptote?
Yes.
Where? Why?
Because
Divided by.
the degrees.
Oh.
We have a horizontal asymptote at 2x over x.
Which is 2 over 1.
The x's cancel. Okay, so we have a horizontal asymptote at, that's y equals, by the way.
Oh, okay, I was about to ask. I was just getting crazy.
Well, that's true too, but
I don't think you're supposed to call children crazy. My mom did.
I didn't. You think I'm defending?
Not a sophist.
Is it possible for this graph to touch the horizontal asymptote?
Yes.
To find that out, I'm going to take my original function and set it equal to the value of the horizontal asymptote, which is 2. To solve this, we can cross multiply. Maybe put that over a 1. So I get 2x plus 1 equals 2x minus 6. I'll go with that. 2x plus 1 times 1 is 2x plus 1. And 2 times x minus 3 is 2x minus 6. If I subtract 2x from both sides,
You get 0.
I get 1 equals negative 6. How do you feel about 1 equals negative 6?
Incorrect.
Makes sense.
Okay,
Huh?
the graph does not cross the horizontal asymptote. Do we have any x-intercepts? Let's do the y-intercept first. The y-intercept. What is f of 0?
1 over negative 3.
Negative 1/3. 0, negative 1/3. Do we have an x-intercept?
Yeah.
When does 2x plus 1 equal 0? That happens when
When x equals half.
negative 1/2. So negative 1/2 is right here. All I need to do is figure out what happens. I know what happens in this piece. I'm pretty sure I know what happens over here. What happens as soon as we pass 3? What is f of 4? If you plug the 4 in.
A plus 1 will be
9.
9. 4 minus 3 will be 1. It'll be 9.
Okay, folks, I got enough information to graph this. It's going to approach the asymptote, It's trapped up here, doing something like that. It might be steeper. You could plot more points to get a better curve. Okay, but that's the gist of graphing it. Okey-dokey. We'll press on tomorrow.
I hate this.
Appreciate the number.